And welcome back. I'd like you to imagine that we want to prevent an unauthorized person from coming into our home or into our office. How do we prevent that? And you might think, well, Keith, we're probably going to use a door of some type and a lock, and that would do the trick. Yes, we could prevent a person from going from out there to in here by having a door and a lock. Well, we have a similar function of that in networking. And one of the options to implement that type of blocking or stopping of traffic is use a firewall, like a FortiGate with security policies. That'll do it. Or we could use an access control list in many devices that would say, hey, wait, before I let you through, I need to check you. And if it says, well, you're coming from this IP address or that MAC address, or you're going to this destination, we can stop it based on an access control list. An access control list can be used depending on the platform, not just on a router or a firewall. They can also be implemented on switches. So we can actually stop traffic from going within a VLAN by simply setting up an access control list. Now, another option for stopping traffic within a VLAN is simply on the VLANs to not allow intra-VLAN traffic. And that way the switch port won't allow traffic between two ports in the same VLAN. But there's yet another option I'd like to share with you today, and that is the concept of a private VLAN. So regarding FortiSwitch and what we can do, all those options are available to us based on the platform and the license that we have on our FortiSwitch. So on our FortiSwitch, let's imagine we have some ports in VLAN 10. And what we can do is we can set up access control lists to control what traffic is allowed through the network, even on layer 2 switch ports. So here on switch 1, if we go ahead and minimize system and go down to switch, here we have an option for ACL, access control list. So there's a whole bunch of predefined services that we can use in combination with MAC addresses, layer 2 addresses, as well as layer 3 addresses as we build our access control lists. So these are all the ones that are built in by default, but if we had custom protocols and port numbers, we could click on add service and add them as well. And then we can leverage those inside of an access control list that we create and apply on our switch. So let's imagine we want to create an access control policy. We'd click here on add ingress policy. And ingress implies traffic that's trying to go into the switch port. So you have a device that's hanging off of a switch port. It'd be traffic from that device going into that port. So we could call it 1. We can specify which interface we want to apply this to. Let's go ahead and apply it to port 3. And let's say this applies for VLAN 10 traffic. Then we can specify the Ethernet type. So IPv4 is hexadecimal 800. Let me get out a calculator. So if we go to the, this is Windows 11. If we go to the programmer flavor here, and we put in hexadecimal 800. In decimal, that's 2048. All right, so we can put the Ethernet type 2048, which means IPv4. Then we can specify the service. Let's imagine we want to stop all ICMP traffic. And then we can specify the details regarding source MAC and destination MAC. And let me make sure I have all my details here. So if it's VLAN 10, Ethernet type is 2048, which is IPv4. And it looks like ICMP traffic, which is what ping uses. Source MAC, destination MAC, blah, blah, blah. If that matches up, what do we want to do? So we could just say we want to add a counter, or we could say we want to go ahead and drop it. Then we have options regarding class of service queuing and VLAN tagging and redirection, and we'll click on OK. So now this inbound policy on port 3, we're not allowing ping based on the IP and the MAC addresses for source and destination. If it sees that, it should drop it. So this kind of gives you a feel of some of the options available as far as setting up an access control list and applying it for any inbound traffic trying to go into a port. So I'll go ahead and click on OK. Or if we do want to allow that traffic, we want to make sure we remove the ACL. So I'm going to click on delete, and then that ACL is no longer in force. So that's one way of controlling traffic flows through the FortiSwitch. Now, another option for controlling traffic through a layer 2 switched environment is the use of private VLANs. So to set that up, we go under switch and VLAN. We create a new VLAN, and oh no. Okay, this switch does not support private VLANs. Let's go to switch 5. I think it does. So here on switch 5, under switch and VLAN, we'll click on add VLAN. And sure enough, we have the option here for private VLANs. And if we enable it, we have some additional information to supply. So let's imagine we have an IP addressing space we want to use, and let's say it's 10.60.0.0 with a 24-bit mask. However, let's also imagine we have some people on this subnet that we want to allow to communicate with each other, and we have others that we don't. So how do you enforce that? Well, one thing is you could go in and make lots of access control lists to specify who can talk to who. However, that would be a huge pain and a lot of manual work. And here's how private VLANs come to the rescue. We start off with a plan and an IP addressing space that we want to use. However, what's going on behind the scenes is we're actually creating multiple VLANs. So to pull this off, we're going to create a VLAN. Let's call this VLAN 60. Now, if we just created VLAN 60 and we put all these devices in VLAN 60, they would be able to talk and communicate with each other. And this VLAN is referred to as the primary VLAN. And then in the world of private VLANs, we're going to create yet another VLAN, a secondary VLAN. And the type we're going to set up is called a community VLAN. And the reason it's called a community VLAN is because devices off of ports in this VLAN, they can all communicate with each other. So each of these dots represents a device connected to switch ports, which are associated with this secondary community. And this secondary community, we'll call it community A. It also has a separate VLAN number. Let's go ahead and give it VLAN number 70. And then if you have other groups of computers that you want to be able to communicate with each other, we can make yet another VLAN, and that's also another secondary VLAN. I know it sounds weird because you're like, hey, shouldn't we just have one secondary VLAN? No, all these inside of the primary VLAN, they're all considered secondary VLANs. And this could be community B. And then all the devices on ports in VLAN 80, which is a secondary community, but it's different from the first. All these devices could talk to each other, but they could not talk to devices in community A. So people in one community cannot communicate with devices in another community. Now, the cool thing is everybody's using the 1060 addressing space. So we don't have to create separate subnets for these VLANs. This is just a way of logically controlling which devices can talk to whom. Now, what if we also had a few devices that we didn't want to talk to anybody? And I'll go ahead and create another secondary VLAN. I'll call this one 90. And this secondary VLAN is of a type called isolated. And then all the devices in the isolated VLAN, they can't talk to anybody. So let's imagine all these red dots represent ports associated with this VLAN 90, this secondary isolated VLAN. They cannot communicate with people in community A. These red dots also cannot communicate with devices in community B. And also, they can't even talk between themselves because it's an isolated VLAN. So basically, all these devices, let's say there's 20 or 30 devices here in VLAN 90, they can't communicate with anybody else on that same VLAN, with one exception. And here's the exception. On the primary VLAN, we're going to have one or more promiscuous ports. And the thing about a promiscuous port is that it'll just talk to anybody. So anybody in any of these secondary VLANs, whether it's community A, community B, or the isolated VLAN, they can all communicate with this device right here. And on this port right here, this promiscuous port, which is associated with the primary VLAN, that's usually where we have our default gateway. And that way, anybody who needs to get off the 1060 network can successfully reach their default gateway. So this is the story of private VLANs. So if we were going to put it on place, it'd be VLAN 60 here as the primary VLAN. For the isolated sub-VLAN, it really should say a secondary VLAN because that's what it is. And I'll put that in red, and that is VLAN 90. And then for the community sub-VLANs, we have VLAN 70, which is community A, and 80, which is community B. And that's how private VLANs operate. So we'd also want to make sure on this promiscuous port here, that's where we're providing services like DNS services or DHCP, gateway services, etc. Because everybody in VLANs 90, 70, and 80, they can all reach this promiscuous port. So in a service provider environment, they may have lots of different customers. So maybe this represents customer A, and this represents customer B, and this represents a whole bunch of people that just have one device each. And they want to make sure that in their environment that these devices cannot communicate with each other outside of where they should be able to for security purposes. And once again, private VLANs allows us to use this one IP addressing space, but at layer 2, control which devices can communicate with which other devices. So thanks for joining me in this set of videos regarding working with Forti switches in local mode, or also called standalone mode. And I'll see you in the next set of videos soon. Until then, I hope this has been informative, and I'd like to thank you for viewing.